Hello, welcome everybody to the third class in the. Oop, I'm not sharing it in person. 1 second. Nice catch. We're not sharing this in person. Okay. There we go. Okay. Take two. So welcome everybody to this class. It's the third class in the data management and manipulation in SQL101 class as part of the data analyst track in Omaha Data Science Academy. This is a spring 2025 version. I am Jeremy Bergman, the instructor for this class in Omaha Data Science Academy. So we start with how this class is structured tonight. We just took the quiz over class 1 and class 2. We'll review that after the end of the first hour. There are a couple challenges that we had tonight, so I'm going to fix those up. And the purpose of that, as I've been explaining to the class, is since the content in this class builds upon itself, making sure we remember what we learned last week and we have those skills to be able to learn the new skills this week. So in this class, we'll learn about data definition language. This is defining those database structures and tables and data types and table constraints that contain the data that you load into a database. So it's like all about defining data into tables. That's why they call it the data definition language. In hour 2, we'll learn more about data manipulation language. That's part of what the title of this class is data manipulation and management, doing things like inserting data into a table, deleting it, and updating it, and even importing data sets. That's all like managing data that already exists within a table. We'll also learn about creating views. I briefly mentioned that in week 1. That's where you can save snippets of code and you can save it as a query that you're able to execute yourself. It's almost like a virtual table that you can save some of your code and be able to run it on demand and give it some parameters and so forth. We'll see an example of that near the end of hour 2 at the end of the lecture. And then hour 3, we'll do some examples and exercises with extracting and storing data. And we will also review homework 1, any questions that anybody has on the first part of the project that covers lecture 1 and lecture 2. We'll also introduce homework 2 tonight during hour 3. So that will cover the material in this lecture. And then as part of the project, continuing to build towards the end where we have a full database and queries and analysis for the project that we are completing or project we are doing in this class. Okay. A quick review of class 2. What did we learn last Wednesday? Some of the common SQL clauses. Those are things like from. So where are you getting data from? What tables? Your select is the columns that you were including in that result output or that result data set that shows within MySQL Workbench. So when you write a query, the interpreter brings back a result set for you. That's what the select does. It tells it what columns. You have your where clause that will reduce the number of rows that your analysis is doing or returns. We also learned about functions, common aggregates, and other functions. So we have aggregate functions where you're summing the entire group and you're using group by statements. Some of them are scalar functions. So those are things like manipulating strings. You use group by on aggregate functions. On the scalar functions, you don't have to because you aren't summing by a group or another column or the values of an entire column. There are also some other date functions and math functions that we learned about last week also. Okay. We did learn about utilizing comments for debugging or explaining code, that you could use the # inside of your SQL in MySQL code to denote a comment. I could also bring that up and show it as an example. We'll go ahead and do that. MySQL Workbench. I don't see that I have MySQL Workbench open, so just 1 second. Using this on Windows. Got to open that before class started. I'll show that to you in a minute once that is open. And also, let's see, go back to full screen here. Slideshow. There we go. And also, what are the various SQL function types? I did just mention this. So the aggregate function, you have a sum, an average, and min-max over in a column. You use the group by to group it by is some type of value column. So a value column would be like states, like we did from the world or cities from the world or countries from the world.city table. We would sum, for the world.city table, we would sum over all of the cities, the population, and then we would group it by countries to get the total amount of people in that country for the cities that are in that database. And then value and scalar functions, I also mentioned that on top. So these are ones that change every single value in a table. It goes one by one. Things like string, you can replace strings or find strings, get the left and right portions of the strings. There's a whole library of them that you can find in SQL documentation. You can do dates, so you can do a number of things like changing date formats or date time formats. You have a wide variety of date formats also. You could start year, month, and day. They could have dashes or forward slashes. There are a whole bunch of them that you can do, math functions and so forth. And all those still, like I said, have in common that they go by each value in a column, in each row in a column, and they change the values of those. They change the values of the values that exist in the table, and then they return that as part of the query. So they don't change any. Tonight we'll learn more about how to change the actual values in the table. This is like functions that determine your output and your output result set. And we'll change and manipulate that. So for this class, we'll learn about how to change and manage the data that's actually inside of the table, that you store inside of the table. So the objectives tonight are creating and deleting a database. So that very top level container that contains all the database objects. Creating and deleting tables and views. So those type of things, containers, the tabular containers that hold data. Views are like an abstraction. So you can create a query that queries a table, and then you can run that on demand to get the results. So it saves the query, but it also acts, you can query a view also. So you can give the view some parameters to be able to change the output. And we'll see that in action near the end of this lecture. Creating tables with constraints. So one of the big things of relational databases is that it is what you would call tightly casted or tightly formatted, so highly structured data. The purpose of the database is to take structured data and put even like more and solid structure and constraints on it. So things like making sure that values aren't too far out of range. So perhaps a system, I think there's an example recently of some bank crediting a customer like $1 billion. Of course, that's by accident, or a few $1 billion. Of course, is by accident, but if you put table constraints on it and other system constraints and other table constraints, perhaps maybe that should not happen, that you'd be able to do that. So the transaction would try to go into the table, it would look at that value and say, is this value valid or is it not valid? So you're really tightly putting constraints on the data that you're allowing into the table, tightly casting those. We'll also add and delete table fields. So after a table already exists, you can add a field and more data to it, that table.
Hey Jeremy, is your
Yep.
screen? Are you on? Your screen just still says review class 2.
Oh, it does?
Yep. So I don't know if it's frozen.
Okay. I am using the connection here tonight, so it could be that. So let me go ahead. Yeah, it shows class 3 on my screen. Is anybody else having a problem with that? They see class 2 online?
Yeah. It says review class 2 writing queries.
But we're talking about stuff on. I printed them out, and you're talking about stuff on class the slide.
Yep. When I looked at it, it showed that we were on class 3 objectives. Is anything I'm saying like coming out delayed or anything?
No, you're fine.
Your audio is fine. I just I printed the notes, so I'm following along, but just for everybody else online,
No, that's good to know. I think I switch over my connection. Do you see class 3 objectives now?
It still says 2.
It still says 2. Okay. Let me see. Let me see if I remove it and add it back to the stage. Does it say class 3 objectives now?
It's still loading.
Okay. Maybe this would be a good time to just charge up my phone and switch connection. That seemed to work the best. Go ahead and do that. Give me just 1 second. Did it appear for anybody yet? Must just have the worst Wi-Fi connection here.
It's black. Just a black screen.
Okay. I'm switching to my hotspot really quick, and this should. Yeah, I was hoping with this new laptop I got, it had like a higher powered Wi-Fi adapter, but it seems to just be the connection here. I thought it was my machines before. Part of it is StreamYard. But if you have a good connection, okay. Am I back with everyone? I just switched my connection. Okay, from current slide. Everybody sees class 3 objectives?
Yes.
Yeah, my mobile phone has a better connection than the Wi-Fi here, which is crazy. Oh, well. Okay, let's go back over that. So class 3 objectives, we're all about data storage, and then data storage as far as creating and deleting databases. So that big container that holds database objects such as tables or views that allow you to store data. Then you can create and delete tables and views. So the tables are those tabular structures that actually physically allow you to store data. That data can come from systems. It could come from pipelines that you build, Excel files. I'll actually import one tonight from CSV file. You can manually insert these values. Number of way you can do it, but the table defines that tabular structure. Views are like an abstraction of the table. You could save a SQL query in a view, and then you could query that view as if it were like a virtual table. And then we'll see that in action tonight to make that a little more concrete. But it's very valuable, especially if you're creating reports from a system database. You can just save your code the way you want it for the report, and then you can go out and run that view and produce your results. Plus, then all of the SQL code and logic that you build into it is saved. So whenever you log out of the database, you can go back in and run that view and get the results that you need. Right. So creating tables with constraints, the word that I was looking for, the phrase I was looking here is strongly typed. So constraints on a table define what values within a column can be inserted into a table. So while I was providing the example when everybody's screen wasn't caught up of recently a bank, I don't remember which bank, but I remember hearing it on business news. They credited a customer like $2 billion into their checking account. So the constraints would, if you had a constraint on your database table, that data was going into a database, you would say potentially like reject the transaction if it was over $1 million or whatever limit you would set to it. And then it would give you an error, and then you could provide an error message and review that transaction. So surprisingly enough, they didn't have those type of safeguards on their system. But when you're strongly typing data in a database, it is valuable to do, and we'll see that in action also. So strongly typing the data that goes into your, strongly typing and structuring the data that goes into your tables. You can add and delete fields. So once a table already exists with data in it, you can add another field. Perhaps you need to capture some more values. Adding a field would be a potentially good choice to do that. You can delete table fields also. For whatever reason, if you don't need a database table anymore, if you don't need a database table anymore or a field, I don't know where that beeping is coming from. Oh, we have one we'll make sure all the mics are muted. That might have taken care of it. Okay. So where was I? So adding and deleting table fields, you can add fields to capture additional information. If for whatever reason you want to delete a field, you're also able to do that in a table. That would delete all of the existing data in a table. You also have some keywords here: insert, update, and delete data from tables. These are like your they're like your clauses in SQL, except now we're using data definition language to define your tables and your structures, and data manipulation language to change the data that's inside of the tables. Being able to insert, that does new records, update, it looks for values to update on existing records in the table, and then you could delete records also. So all commands to be able to, the data manipulation language, all to manage the data that's actually physically inside of the table. And then last in this class, in this lecture, we'll work on importing data from SQL and CSV files. So you can write commands to insert data. So you can manually do that. That's what some systems do. Or we can import CSV files like a lot of data analysts do. We'll do both of those in this class. Okay, those are the objectives. So I show this slide a lot in this class. Just it gives you an idea of where we're at and what we're learning from, like what is the need for data manipulation within relational databases. So two of these big ones are manipulating data and storing and retrieving data. Some of the things we did in the first week were performing common queries and aggregations. That's transforming the data that's inside a table. So taking that raw data or that data that we've strongly typed within that tabular structure and translating it the way or transforming it the way we need to see it. These are more about creating the actual physical stores of data, whether it's a database or a database table or a view, and then modifying the data that is actually that's already in the table. Whereas transforming data is where transforming data is just taking that data and presenting it in different ways. We'll also do this with importing. So we'll create a new data set tonight.
Is extraction and removing data the same?
Yeah, is extracting and removing data the same?
Yep.
No, I was looking at extraction as like extracting it from a CSV file or a system. So creating new data sets from another data source or another system. But extracting and storing data is also similar. Also, we're extracting the data and storing it. So storage and retrieval. These two they do overlap. Okay.
Thank you.
Yep, you're welcome. So creating new database and schema, the purpose of this is creating a container for persistent data storage and retrieval. That's what we talk about, is like that container that stores tables, views. And at the end of the class, we'll learn about some advanced features like stored procedures and functions. So you can create your own functions or your own repeatable pieces of code. That's what they are. But a database, you can store all of those. You can store all of those objects that allow you to do certain things within the database. Okay. So what we're going to do for this exercise tonight, or our examples tonight, is there's a database called Classic Models. It's a retailer of scale models of the Classic Cars database. We don't have this installed on the server, but we will create tables as though we're creating these inside of this database. So some of the information it contains is customers, products, sales orders, sales order lines, etc. So the entire database does. We will create one of the tables in this database. So the very first step to this is actually creating the database. This would be Classic Models using code. So I'm going to show you how this works. I'm going to open up MySQL. I'm going to go ahead and exit out of this MySQL Workbench. Show you how creating a database works. In MySQL, they call this schemas, but database and schema is interchangeable in MySQL. And I may have to wait for that to come up. let's take a minute to pull up my SQL workbench. There we go. It's doing it very slowly in the background, it seems. Let's see if it is opened. I seem to be having some problem opening it too. So let's go ahead and do this. Let's go ahead and take a 10-minute break. I'm going to restart my computer because for some reason my SQL workbench doesn't seem to be opening with these other tabs that I have open. So we'll take a break and I'll troubleshoot a couple things here and we'll be right back. So give everyone a 8-minute break, just long enough to restart my computer and get things back up and running. And we'll restart at 7. So be right back. Okay. You'll grab a snack or a green beer for St. Patrick's Day. I don't mind.
Thanks, Jeremy. Too bad we can't share.
Yeah, cheers. Yeah. Just seeing everyone else for St. Patrick's Day, enjoying themselves or having a green beer. It's tempting, but class to teach tonight. All right, I'll be right back. 1 minute. Right. Hey, everyone, I'm back. Say that fixed it. I have a bad habit of not restarting my computer often enough, or just leaving everything open until it slows things down. So that's all it was. Just needed a kick in the rear end. Now it's good to go. So I'll give everyone another minute or two and get resituated.
Just a quick question before you start.
Yeah.
Where are you able to find the quizzes scores? I submitted it and I haven't clicked on put my email on there, but they didn't send it to me yet.
Yeah, I can release the scores to you. One thing I was having a problem with, I'm having a problem with one thing.
Oh, okay.
I need to take a look at. Let's
Okay.
see.
Yeah,
So I can see. Yep, I turned it back on to be able to see people's emails and the submissions.
Okay.
I think I must have it on manual review instead of auto review.
Okay, probably. All right, sound great. Thanks.
Yep. I'll just show everyone real quick. It looks like just about everyone's taking it now. So not to single anyone out, but when I look at it, it shows 0 out of 0 for everyone. So everybody else is seeing a score that I'm not for some reason. I need to take a look at that.
On Slack, I sent you my screenshot that gave my score.
Yep. Appreciate that. And I can go back and fill these in and give you a score too. I must have it on some setting for manual review here. Also, I don't know why I did that in this class or went back to that. Because I give everyone their automatic grade and then I review it and then I scale it up because I'll give you points for answering the question and some feedback on it. Or it'll give you like a 0 out of 1 if you just miss one of the check all that are true. So I go back and adjust it and give it like most credit or partial credit. But it's not showing me anything here, so I'll have to go back in and take a look at the responses and I manually give everyone grades. You received a grade, but manually go in and give people grades too until I figure it out. But we'll cover these. We'll cover these after we get through this first part of the lecture, of lecture 2. So that's the last lecture. Current lecture. Okay. And we're still live, so I can continue recording. I'll go to full screen. So I did want to go back to this because there's a question about it, and I didn't do a great job of explaining it in the moment. But the idea is that we are actually doing 3 of these. We are creating new data sets and combining disparate data sets. So we're going to create a new data set tonight by creating a table and then importing it. And what I mean by that, is the extraction of data. This is part of like being a data analyst or extracting it out of systems or spreadsheets or wherever else and creating those tables. So creating a new data set would be like creating a data and relational database. And then in the next class with joins, we'll learn how to combine all these disparate data sets that you create. So you can start bringing those together in different ways, appending them or joining them. So in this class, we are creating new data sets. The biggest thing is that we're adding, removing, and modifying data directly within the tables. So we're manipulating data. And then we're storing the data permanently to be able to retrieve it. So creating tables and database and those structures, so that whenever you log out, all the data persists, and that you can go back to it and then retrieve the data through querying the table, like we learned last week. I think that one's a much better explanation of the intent of this slide, I believe. Did that better answer the question for Syed? I think you asked it.
Yes, thank you.
Okay. Yeah, there are different disciplines in data. I used to teach a class or one lecture in this class about enterprise data and then like how to extract it. So enterprise data is like anything that can come from different sources. Like often they come from systems, but not always. It may come from like forms or web services or like services that you can connect to with Python program to get data. Or any number of things that you, any number of systems and like the flow of data. But I started to do that more in the data engineering class. I moved it to that to just focus on SQL in this class. So that's really was like about the extraction of data. We'll do some of it in terms of like relational databases and understanding, but we don't have a full lecture on it anymore because some people were mentioned or prior students mentioned, and this is like a lot to cram into 4 weeks and 8 classes. So I agree. So a lot more about extraction. I do have a bonus slide on that because I used to teach it in this class that I'll send everyone to you if you want to learn more about extraction from enterprise systems and the flow of data and things like that. I think it's relevant because it gives you the big picture of how data works within an organization and getting it from all these different data sources and then putting it in a relational database or whatever it might be. Took it out of this class, but that's the idea, is being able to take data from different data sources and then creating a new data set within a relational table in this class, being able to add, remove, or modify it, being able to manipulate that data that's physically inside the table, or being able to query it, being able to bring it back and display it the way you need, and then permanently storing it. So it's like storing it to be able to retrieve it and then being able to change it once it's there. Okay.
I was just thinking, because like you never want to mess with the original data. You want to like make a copy of it to mess with it, right?
Yeah, you almost always want to do that. That's one of my disclaimers coming up is I've personally caused a lot of trouble with like deleting records or updating a record or something like that.
Do it in the copy of it.
Yeah, do it in the copy of it. We'll learn how to copy some data over in this lecture too. Yeah, you can cause all sorts of problems by putting, like putting the wrong values or updating the wrong values inside like a production database. So all of a sudden, like you update a date and then nothing works inside the system. Yeah, like a production database. Yeah. So a production database is like one that's live and people are using. That's like the worst thing that you could do. And so I've been there and try to teach others how to use that with safety if it's the case. I would always just create a copy of the data or just extract it or have the systems administrators just extract it. Sometimes they get picky about what you're doing on their database as a data analyst, which is a longer discussion, but anyway, yeah, it can cause the using some of this and changing data. You want to be really safe about it. We'll talk a little bit about that. All right. And even unintentionally, you can do things that are unintentional. You could update intend to update one or two values, and then all of a sudden it just ripples through the whole table or multiple tables or the whole system. You have to be very careful when you do it. But relational databases give you that capability to be able to do it. For a number of purposes, there are good reasons to be able to do it. Maybe someone's personal information changes, or a date changes, or something like that, and you maybe marital status changes. You go in and update that inside a transactional table or a customer table. So there are legitimate reasons why you'd update, or you have new customers, so you insert a new customer. Usually that's not as dangerous as updating or deleting things. But we'll get to that. We'll get to that part. Okay, so this was to create a database. I restarted my computer so that we could bring up my SQL Workbench. And you will not be able to create this database because I don't give you access to do it. But the statement is create database, and then whatever you'd like to call the database. And this use statement tells the database interpreter what database you're pointed to, or what is the active database that you're using. So those two keywords will be able to do that. And let's use this example out of here to create the classic models database. And I'll show you what this looks like. You can create classic models, and then you could point to that to make your active database. If you select this lightning bolt here, it will execute anything that you've highlighted. So Chris said create database success. It says one row effective. It really created that database table, or that created that database or schema, and then use classic models. So you don't see it here right away because you have to hit the refresh button. And there you go. You have the classic models database. But like I said, I did not give users permission to be able to create the database. It's pretty straightforward though, with those those SQL keywords that you're using to create database and use. And remember, those keywords are always, in this class, we always capitalize them, and then they show up in blue in my SQL Workbench. Okay, so that's how you do that. Now you can start storing tables, views, stored procedures, and functions, those database objects. Okay. And if we go back here. Oh, now once we've created a database, we can start creating tables inside of that database. So the purpose of creating tables, creating that tabular structure for persistent data storage and retrieval. In transactional systems, it's also to capture transactions that are coming out of systems. So in the same way, you have that tabular structure. It's taking all these transactions from systems. Maybe it's ERP system. So an ERP is like supply chain, sales, and inventory management, and so forth. And then when something changes or a sale happens, you capture it within that table that you've defined. And that way, that record is stored, and then you could retrieve it by query. So you could look back at like the previous week and get all sales of some type of widget or object, and it's stored there inside the table because the system captured it and stores it there for persistent storage. But first you have to create the table, and you have to strongly type it to be able to capture each transaction. Yep. So it's like really like giving it like the columns a name, giving them a data type, and these blue are constraints. So we talked about the type of constraints that will only allow you to enter certain values into it. And then some of these will say, we don't want any null values in the customer number. Or if there's no default state entered for the record, just default to any for Nebraska or default to USA. This one's a check. So this last one checks the constraint to make sure that the credit limit is never over $1 million. So if you're to insert a record into this customer table where the customer has a credit limit of more than $1 million, it would give you an error and say, this is an invalid record. I forgot exactly what error message it is. We'll try to insert a record here to show you what happens if you do something like that. And then it's also strongly typed in the sense, those are strongly typed columns. You're defining all the columns. They all have unique names. And then a primary key. So what a primary key is a direct connection, directly relates to another table in the database. We'll learn more about this in the next lecture where we start joining the tables. But if you have a primary key on one table that matches a primary key on another table, that is the field that allows you to combine two tables together. So imagine customer numbers in two different tables. Say there's a customer number in, we'll use the supply chain example, the ERP example. Say when a customer buys something, it records that item, the price sold, and that customer number. Then what you can do is in that transactions table or that sales table, you could join customer information by customer number. So on the transaction, you could get all this information about the customer too. So it allows you to start combining those data sets. We won't go into it really tonight because we'll go into it much more and we'll go into it in depth on Wednesday for the next lecture. But that's how you define these tabular structures within a relational database. There are also things called foreign keys. They're largely indirect primary keys, but we'll learn about that in when you join tables, and then more about designing transactional databases and tables, and then analytical databases and tables. So that will be lecture 6. So that will be next week. But for now, know that you need to create a table and give it a table name. You have to do schema.table. You have to give it all unique. You have to give it all unique column names. You need to give them all the data types that they need. So if you gave something a varchar 50 and it ends up being longer than that, it'll truncate the data. So if you had an address that's more than 50 characters, it would cut off part of that address. The database would give you a warning and say the data is being truncated. So you really want to make sure also you're defining these fields in a way that captures the data correctly. So that's what's really like strongly typed about it. And then the type of values that are there by default or not allowed, or not allowed or default values. So you never want a customer number, or you never want a record that doesn't have a customer number on it. And if so, you can have the database say that there's an error. Let's go ahead and do this. We can do this one as a class. If you have your Examples PowerPoint SQL file. I have in lecture 3, slide 6, it's creating tables. I'd like you to create this in your own schemas and make sure it's successful. So I have mine as J Bergman, but you would put your first initial and last name. And then as the schema or database, and then your table names customers. So if you run this, of course it says unknown database, J Bergman, because I never created my own database. So I'll even show you what this looks like. Starting from that previous one, if we create the database, I don't give everybody permission to create databases. In this, I give you your own database to be able to create tables and play around with it and everything, or query the world or Sequila databases without deleting them or doing anything like that. So that's why I'm saying it's easy to run a command. Learn this by experience. Run a command that accidentally deletes a table or a database or a table, and then it impacts everyone else. Or inserting values into that. Everybody's like, oh, why did this work for you? Then it doesn't work for me, or this table doesn't exist, or the database doesn't exist anymore. It's because everyone was like, somebody accidentally deleted it or something. So I give you select access. Yeah, so that's part of database administration is, learn about it in this class. We covered it as part of the transactional language in the first lecture. They have some like rollback or commit type features for database administrators to be able to go back if something happens, if there's errors in transactions. And all the best database administrators would have like a disaster plan for whatever can happen. Hardware fails, or some data analyst or data scientist goes in and deletes a whole bunch of records, stuff like that. But there, yes, if you were to take a database administration class, that would be part of it, like rolling back the tables and changes and making sure transactions are being stored properly, and then designing the database and database system for efficiency for what you're trying to do. He talked about doing that class, but it's pretty specialized skill set. But if you get into database administration, you can make a lot of money doing that.
That's true. So, but like, how do we create a table then? Like, which just use any of the data sets? Is what you're saying? So we don't have like the ability to create a database. We can create a table from just one or the other.
Yeah. So you'll create a table inside of your schema or your database that I provided you for class. So it'd be like your first initial and last name. Yes.
Okay.
So yours would be C. Mitchell.
Yes. Okay. All right.
So for that example, Celeste, you do C. Mitchell.customers. So you're creating a table in the C. Mitchell database, or so you're creating a table, and it always goes database name dot table name. So you're pointing at the interpreter to say, create the customers table in the J Bergman or C. Mitchell or whoever else's database. And then when you run this code, you've already defined all the columns in the database. So when I do that, it doesn't automatically refresh. So if you hit refresh, you'll suddenly see this arrow under tables, You can see that customers table you created. It even gives you some metadata about it. There are things that you can do is see all the columns on the table, and you'll notice that those are all the same as what we had in the code. You don't have to worry about indices too much in this. That's just database administration optimization. Your keys and your foreign keys. That's what we talked about, like indirect relationships. We'll learn more about that in class. And then triggers, we'll learn about that in the very last lecture about advanced SQL features. So a trigger is like if one value is updated in the database, you update or do some other action on the database also. Oftentimes, if you update one value, you want to update another value. And you can provide triggers to do that. And we won't go super deep into that at the end, but knowing that it exists.
Jeremy, do you quick question, do you bake that trigger in as you're creating the database, or do you add it on later?
You add it on later. So it's like a function that you can add to it. Oh, let me explain. Usually it happens once you start to like insert data. It's like on an action. So when you update a value or you insert a value or something like that. So really you do that after you add the table and you observe the table. And like when you enter a value into it, you add a trigger to do other things. That wasn't a great explanation, but I'm always like, if I'm adding a trigger to a table, I'm always like testing it. So I'd put like a new record in, and then I would do it on update, a trigger on update, and then make sure that works correctly. So I'm like constantly like inserting a new record and creating and then running a query, or I'm updating a value and running a query to make sure that that trigger is working the way I expect it to. So does that answer your question? Kind of.
Yes, yeah, kind of. I'm not seeing it, in real life being done, but it does answer my question. Yep.
Yeah, it's more of when you are. I'm trying to provide a real life example. Think of when I'm thinking of one. It's more when you're designing a transactional database, not really analytical database. I honestly don't use triggers that much. We just cover it at the end myself. But let me think of one. Perhaps like you have a new customer, and if their age is over 65, you want to classify them as like a senior citizen. So if you insert a table or you insert a record of a customer, and that's inserted, and then upon insert, that's how you would define a trigger, or upon update or after update. If it saw that they're 65, it'd populate another table to say senior citizen. Often, and you could do that don't want to go into it too much because there's some stuff that you can do without creating a trigger. But that's the idea, is that when a record is stored in a table, is that the trigger will update another field or delete a record or do something upon that event happening. So yeah, there are a lot of considerations. You can see there are already a lot of considerations when you're designing a database and database tables. It's not working for you, Celeste? Let me see if I can refresh. Make sure also you hit the refresh button. That's a common. Now you can see your tables. Yeah, it doesn't refresh them. IDEs will refresh automatically, but this one does not. Okay. So I'll go ahead and keep moving through this. So we have,
So you can see my screen?
I could see your database in here. So I can see everyone's database. Not everybody can do that because I didn't give them permission to do that. See each other's databases, or like add databases or delete other people's databases. I just give you each user the permission to be able to create tables, pretty much do anything inside your own database, and then be able to select from the world database, the crypto database, and the Sequila database. So
that will be persistent when we log back in.
yep, it's persistent. So yeah, the idea of persistence is a big deal in database. It's a database that stores data so that it's there. You go back and it's there whenever you log out or even shut down the database system. It'll still store the data unless you delete it or do something like that. Yep. And that's big. That's really big. Or if you restart it, it's still there. Okay. We'll keep moving through this so we get a good third hour. All right. So SQL constraints, we actually talked about this pretty thoroughly. Constraints are rules enforced on the data columns of a table, and they limit the type of data that can go into it. So I explained that in the last slide. It ensures the accuracy and the reliability of data in the database. I think that's key. Otherwise, there could be all sorts of junk or garbage installed or inserted or in tables. But in reality, you will see that in databases. Sometimes the IT guys, they don't like to give you access to the database for that reason. But if you're really designing these as those strongly typed and the databases with these constraints and stuff like that, it helps avoid some of that. So column constraints, these are the values that can go into the columns. You have null or not null, as we explained. Ensures a column that can only have or cannot have null values. It would be strange to create a column where the constraint is null, so every value is null. But maybe there's a good reason. Maybe it's like a placeholder for a future column or values or something. Then default, you could do a default value, like we did default NE in the state table or in the state field. So if nothing was inserted, it would default to, and the state would default to NE. Unique ensures that all values in a column are different. That could be really important on a key value like a customer ID. So if it is a field that you want as a primary key, all of those values need to be unique. And you may put a constraint on it that says all customer IDs have to be unique. Index is a type of constraint. It's more of a database optimization or database management administration task. But you can create an index on a table to be able to query it very quickly. Maybe you index it by year. It's a huge table. You index it by year. So your query doesn't have to go through the whole table. It can just go through 1 year or 2 years or 3 years. An index is like it sorts the table in a way to be able to access it faster.
Is there something like, rather than like putting in any value, like is there like the concept of like a drop-down box, like pre-selected values? Is that something we went over? Or we will go over?
Yeah, usually so one of the things about constraints is usually they're built into a front-end system so that you can't enter certain values, right? So front-end system is like your the system that you use for your nonprofit. Be able to manage it. It'll have a bunch of drop downs.
Right. That's the front end system.
Yeah. A lot of times the integrity checks are built into some front end, but you can usually also build them into back end like this. Yep. To make sure that the database, the data that's going into the database has the like data integrity that it needs to be able part of it. But it's better oftentimes built into the front end because you want to notify the user that's invalid.
And when you're talking about database administrator, that's like a database administrator role, kind of like allowing or not allowing, like, for a drop-down box, like creating values for.
That would usually probably be a developer, but the developer would work with like a database administrator or some type of database analyst or engineer to build a data model that does that or captures it correctly. So it's usually a team of, and especially in big organization, a team of people. A small business, maybe you end up doing it all yourself. But anyway, table constraints. You have your column constraints. You also have table constraints. These are your primary and foreign keys. I said your primary key uniquely identifies each row and record in your database table. This is a huge part of a table of relational database. The importance of relational databases is completely like just saying the word relational. So being able to take two tables or disparate data sets and be able to relate them together by primary key. Covered that example also in the creating tables because you could have a transaction table with a customer ID. You could have this customers table with a customer number and then be able to directly relate those by primary key. So it connects the two together. It relates the two together. That's important to define those in a relational database. That's like the whole idea of the concept of relations and relational databases and the ability to be able to do that. Foreign keys are like a primary key. It's just like an indirect key. A foreign key might be something that repeats in one table and doesn't repeat in another. So we could use that transactions example. A customer may have multiple orders. It would be a foreign key to the customer table since they do directly relate, but they're repeated. The customer repeats in one table and doesn't in the other, but you can still relate them together that way. And we'll learn about the different types of relationships when we talk about joins. And then checking constraint is making sure that the values in a column satisfy certain conditions. You could think of this as a column constraint, consider it a table constraint, that it's a constraint on the values in the table that are inserted in the table. Okay. You can do a few things modifying and deleting tables. The purpose, pretty straightforward, changing or deleting a tabular structure from the database. So I'll run some of these for you. I'm just going through these now so that we can get to some guided exercises in the last hour. If anybody needs me to stop or slow down, just let me know. So you can do things like alter. Yeah, they are pretty small even on my screen. I think that's probably better. Okay. So we can do some things like add a column with a certain type. So notice when I have the customers table, I don't have any column called column name, and that's what we're doing. We're adding a column called column name to this. with that data type. So whenever you add a column or you define a column, it must have a column name and a type to it. Go ahead and run that. So it ran successfully because we have the green check mark. We'll refresh it to be able to see that result. We'll refresh the table. Refresh all. Yep, there it is. I almost didn't see that. That one's pretty small too. So let's go ahead. I don't know if I can zoom in on this one.
It's not as important because like, you know, like be able to see what you're actually writing.
Yep. So we did add column name, and I didn't see it for a second, but it's a small guy right here. And then you can also drop a column, which is like deleting a column from the table. If we run that, ran successfully with the green check mark. We refresh this table. And then it's gone out of the table. You can even do things like adding a constraint or dropping a constraint. And you could do things like give an alias to different constraints and then drop those constraints. I don't go too much into it right now because it's complicated, but like a foreign key, you could define a foreign key or a few foreign keys. You could give it an alias like customers _IBFK_1. And then if you decided that you didn't want it later, you could drop it. Or you could drop other constraints. That's a table constraint. What's that? I think sometimes it just gives it a random name. I don't know where I got that name from exactly on the table, but you can drop other constraints like nulls and stuff. You can give those aliases to. So you can do that with either column or table constraints. Usually it's like a table constraint that you're dropping, but you can drop or delete the table. Go ahead and do that. Yeah, I don't name the table constraint here or anything, so I don't think this piece of code will work. We'll just try to run it. Yeah, it says I didn't name that constraint up there. So it gave me a red and says error code. That's a good example of an error code. 3940 constraint doesn't exist. So if you name the constraint, you could do primary key as constraint name, like we did the aliases in the queries, in the select queries, on the fields in the select queries or tables. Okay, so what else do we have? We have alter table. We did drop column. Drop or delete table is the next step. So you can drop this table if you don't want it anymore. That's probably one of the more dangerous ones. Sometimes if tables have constraints or primary keys and constraints on them, it won't allow you to drop a table until that constraint is removed.
You can put a constraint on it.
Yep. Then you have to remove all the constraints and you can delete the tables. But now we see that table's no longer there. So I do want that table back. So what I can always do is run that same create table statement. Just wanted to show it for illustration purposes. And then you have your tables and your customer tables back. So you can always bring it back, but the problem is now all the data's gone. If there was data in it, now the data's gone if you drop the table. You would have to do something like rolling it back. Yeah, what you were talking about with the database administrators, like rolling back the
So,
delete.
Okay, so why would you do that?
Why would you delete a table?
And then, like, yeah, and put it back, but the data's not there. I don't understand.
Because you made a mistake or something. If you deleted a table by accident that had a bunch of data in it, when you recreate this table, there would be no data in it. So you delete the table and all the data in it when you do delete table or drop table.
But can't you just add it back before you do the first place?
You could, assuming that you could reproduce that. Maybe you don't have a backup of it or something, or if a system generated all those, say it was like transactions in the past, there may be no way to reproduce that. So, like when something sits there, it persists until you do something to it.
But you created it in the first place, so can't you just recreate it? Oh.
Only if you have like a backup or some type of rollback in place for it. So there's no like, that's the challenge with deletes or updates, is that if you don't have a way to roll it back, you can't go back to the previous value.
Oh, because it's like it's like a point in time, right?
Yeah, it's a point in time.
Okay.
Yeah. So I'll go ahead and let's see. And we're running a little short on time here, and we haven't done inserts or anything like that. So we've really done like being able to, the DML piece of it is drop, create, alter. I'm going to give everyone a short break, like a 10-minute break. And then we're going to do insert, updates, and deletes. So that will be like data manipulation language. So we'll come back, give everyone 10 minutes. And then we'll show everyone how this data works inside of these tables. And then copying tables. And by the end, we'll have our own exercises, import our own data, create a view, and then we'll do this exercise too. We have a lot to cover, last hour and 45 minutes, but everyone take a quick break, give you 10 minutes. Let's restart at 8:45. Grab a green beer if you need it. Hold on tight. Got a lot to cover the last hour.
So is there a way to continually update the data so that, it's not at a point in time thing?
To continually update it. Yeah, systems will continually update it. Is like if somebody changes their marital status to married, like you'll go and update the customer record. But there's not really a way to roll back or go backwards. Say you made a mistake and labeled someone as married and they aren't really married. In your head, you could do that. You could go back into the system. But there's no mechanism inside of the database unless you explicitly, database administrator sets it up. So like imagine something like somebody's password and it's like some 20-digit character. If you overwrite that, there's not a way to know what it was before that unless you're able to roll it back or you re-enter it into the system.
Oh, that's a good example.
Yeah.
Those are good, yeah.
So you can imagine how critical that would be. Like I've done it before, so I'll even list my mistake is that I was importing data. And so that went in and it was updating a bunch of records. Imagine this on a scale of like 1,000 or 2,000 or 10,000. You went in and updated and it entered all these gibberish values for all of these houses and properties, and you go and look at it and you have no idea what they were before. Somebody would have to, what they ended up doing is having to go to a backup at a point in time and then redo all those values. Otherwise, if you didn't have a backup, they could just be lost forever. So being really safe about inserts aren't as critical usually. Insert a new record because you still have all the other records unless you insert information that causes some issue, but it's almost always the updates or deletes that cause the biggest issues if you do it wrong. Especially an update, I just hold my breath on that. Like sometimes if you miss, you'll see if you miss something in your condition, like your wear condition, it could have massive unintended consequence. If you delete a record, it's usually not that bad because, well, if you have a backup, you can just reinsert the record at some point in time.
So if you're dealing with like a cloud-based like database, would you like call those people, like call their help desk then? You probably wouldn't do it.
If you deleted
You wouldn't have access to it.
messed up information in their database,
Yeah. Like, you would have-
I mean, maybe. I wouldn't assume that though. It makes me hold my breath. I always just make a copy of the data and then just put it in my own table, and we'll see that here when everyone comes back. As a data analyst, the last thing you want to do is mess up a production system and the integrity of the data in it. You may not have a job if you do enough damage. Usually they're forgiving and have a backup or whatever, but I have learned to just take a table and export all the data and do whatever else you need to do with it. Don't change it in production. And we'll actually cover the quiz here in the third hour. I want to make sure we get through lecture and we can cover the quiz. Doing it in reverse order a little bit today, but I want to give everybody time to work here at the end of class or ask questions. But it's always good questions by everyone. I enjoy answering them. Making sure I don't go in too deep, but answering the questions that you have, I appreciate it. Appreciate the engagement. Oh, what happened to this quiz? Okay, I'm gonna release the scores even though they all say 0. I don't want to do that. It's getting a little chilly. It is a little chilly in here, especially compared to the summer day outside. I did something. I set it to manual review then, and then it said everyone's scored is 0, but it did turn on email. So I need to release the grades after submission and then turn on the email, be able to log in by email at the same time.
What email addresses?
Should you just responder input?
That's okay. 'Cause I thought that because that's what it was at, but it like, so it should have had Michael and Sia and it should have come up to mine. That's what I thought was happening, but I wanted to be sure. That's why I asked. I thought it was.
I might just have to, since the settings were all wonky when people were answering this, I just have to go in and review them myself and give them scores.
I sent my stuff over, but it's not the best. It wasn't the best format.
Yeah, so I have Samuel's and Matt's and Nancy's under emails. So everyone else, if you can send me a copy of your answers, I can grade them and then send them to you. Make sure those work for the next one. Okay. Let's go ahead and do this rest of this lecture. Okay. As mentioned right before the short break, this is where we're getting into data manipulation language and being able to physically insert, update, and delete records from the table. Even talked about some of the danger of this. Like you can imagine, I think update's the most dangerous. Deleting records, obviously, if you delete it, it's not in the table anymore. And if you query, you won't be able to see it. But if you accidentally do an update that impacts a whole bunch of records, maybe thousands of records with a wrong value, that's probably worse. But all these are obviously things that you can do with database tables to manage the data inside. Like I was telling Celeste, who's here, we'll see how to copy a table and be safe about it and just do everything in your own table instead of a system table where it may impact people's jobs. I think that's really important because that's like what I always do. And most of the time if you're a data analyst, you don't really need to be updating or deleting records and stuff like that in a table. You're just taking the data and analyzing it. But obviously, part of relational databases is the ability to do all this. So it's important to learn about it. And as a data analyst, understanding how systems work and then how that they update, insert, delete data is a key part of understanding the data itself and how it's generated, which is big in analyzing it. Okay. So we're going to start by manually inserting values into a table. Purpose is to store these persistent values that allow for the creation and I should say storage of data. So it allows you to create data in the tables. I don't really like the word extraction, although you can extract it and then insert that data in to a table. I like the word you can create and store the data persistently. Okay. So what we're going to do is insert into this classic models.customers. For you, it'd be your first initial, last name, .customers. And this is what it looks like. You have these keywords insert into. Then your database.table. And then you have the list of columns that you want to update. And then the order you want to do it. So it actually doesn't matter what order you do it in, but whatever order you do it in, you need these values to be in the same order. So if you have customer number, customer name, customer last name, customer first name, you would, if you're inserting values, this is inserting values manually, you use the keyword values, and then you have these open, what can I think of it? Open, not parentheses, but you have the open and closed, not brackets either. You have this tuple is what they call it in Python, but yeah. So that's what they technically call these rows, is like a database tuple, but it's like a list in Python, and it has to be in the same order as this insert. Parentheses. I don't know why I was overthinking it. Please excuse my dear Aunt Sally. That's the one I know from math. I was overthinking it. I'm like, parentheses. That's not thinking as quotes or something. It's getting late in the day. Okay, we need to keep moving. Parentheses inside the both open and closed parentheses. You have to have them in the same order that you insert them into. So customer number, this would be like your customer name, be like this, Atelier Graphique. Your customer name, be then customer last name and first name. So your customer name would be, oh, why did I do that? Customer name. So we have so the customer name is Atelier Graphique. Customer last name is Schmidt. First name is Karine. Phone number is in some format, French format I know about. In that address, you can even insert null values in there if you specifically state null value, and then the column allows for it. So we talk about those constraints. If it allows for nulls, you can put null value in there. And then you have the city, and we're here. That'd be address line 2. Maybe they have nothing in address line 2, so you give it a null value. Then you have city, and then your state. If there's no state in France to put in there, you could also do a null value. Here's your postal code, your country code, and then your sales rep employee number. You can imagine that being like a foreign key to the customer, or maybe a direct key. Maybe the other table is like a sales rep table. And then the credit limit for the customer. So you can see how that is inserted. And then when you do a comma, you can insert a second record too. And you could do this as many times as you want. You could do this 100 times, 1,000 times, 1,000,000 times. That's basically what systems do. They capture information and then they store data in this type of format. It directs like the code underneath the system. It'll be something like this: insert into that table these values that we captured from the system. And then that persists so that you can always go back to the customer information. You can select the result once you insert these values. So when you run it, it'll just tell you if it's successful or not successful. And then once that data persists in that table, you can select it from the customer table. So let's go ahead and try that. Let's see how this works. Okay. So we have insert into your first and last name customers. We already created that table before. We have the columns in the order we want these records to be inserted. And then you have the values that you want to insert. So if you run this, you need to run this all as one, the insert, and then the values. If I hit that, you see down below, I'll say 2 rows affected, records 2, duplicate 0, warning 0. If you were to do something like, let's go ahead and try this on this table, that constraint of the credit limit being over $1 million. Actually, if you were to just do this one again, it will give you an error because of primary key. Duplicate 103 for keys, customer's primary. It's because customer number is a primary key, so all those need to have their own numbers. And since these already exist in the table, it's trying to write another record with the customer ID of 103 and 112. And that's why it gives you that error when you try to run it the second time. So let's actually do something like 143, 172. So now we have unique customer numbers we're inserting into the table. Let's make this one like 7 million, like that bank example where the customer had $1 billion inserted into his bank account. I don't know about anybody else, but I would see that. I'd be booking my tickets somewhere, except nobody had ever let you take out $1 billion. I guess that's some problem. All right. And the bank might not even have it, but that's besides the point. Okay, so we're going to insert these values, but we're going to do this one that violates the constraint here. Yeah, so it did actually, it gave it a constraint name on the table. So when you tried to insert that record, it said error code 3819, check constraint customers, check 1 is violated. And did we give that? We didn't give it a name here, but it gave it its own name by default. So you could edit or drop that constraint too. But you see what happens when you violate one of the constraints on the table. And now if we just wanted to see what data, I'm like, okay, after all that, what is all the values and what are all the values in this table now? So you can do that by doing select star from jbergman.customers. And it's just those first two, because if you have an error when you run the others, it will roll back that transaction and not insert any of them. So you can consider this as being like a batch that it does, and if there's an error, it won't do any of it. So you'd say, what happens if we do, if we just do 771,000, that should be less than the constraint. And it is, it gives me no errors. It did that successfully because that value is under $1 million. You select it, and now we have 4 records, all with different customer numbers. because you have to have that because of the primary key. And we did put the same values in there, but they're just for illustrative purposes, how that worked. So now you see the importance of constraints on table also. Okay. Keep moving. We did been similar here, inserting values into tables from query. So you can do this instead of, and I didn't update this example, but you can create a query and then store those as persistent in a table. So you could, instead of just writing each one of these out, you can imagine how hard if you did that by hand. If you wrote out 1,000 of those, you'd never quite get it right. You can do these values into a table from a query. So you can define a table. And then if you have a table that exists, you notice the insert into, and then your column names in order. If you do a select query, as long as you have those columns in the same order as you defined in your insert to, you can run this part as a query and just insert that result set straight into the table. So this could be really valuable. Like I said, if you don't want to enter 1,000 records by hand, but you have access to another table, you could define that query, put it inside of an insert underneath an insert into, and then have that data yourself in that table. And I wish I would have updated this one for the world example, but let's just try to create one real quick. Let's try to create a world.city query. So what you want to do if you create a table, you want to give it similar data types. Also, if you're doing this, if you're inserting from a query. So what we'll do is go to the world table. Say we just want city. Let's do ID. And then we'll do integer because it's integer type in the city table. So we're going to create a table that does the same thing. We want name. We want, and say we want country code. Okay. And say we just want, we're going to call this jbergman.us. We just want cities in the United States to be in our table that we create from the world.cities table. Okay, so I'm going to go ahead and create that. And actually, I have like the wrong data types here. So if you refresh and you run that, you now see a table.us. But I need to define the name as a character 35. And then country code as a character 3. And you can see that because I clicked on each one of these columns, and then it gives you a little definition right here of the column of how it's defined in the city.world table. And we want to just define those the same way in the table that we're creating. We can set it to default null. That's just fine for the moment. Usually you'd put a primary key on this, so you would do ID. I'm just going to do this real quick for example purposes. And if you already have the table created, what it will say, it'll give you an error. If you try to create it, you'll say table US already exists. So it knows that the table already exists. inside of your schema. So anything about columns or tables in a relational database, you can't have the same names. You can't have the same table names inside of a database. You can't have the same column names within a table. So you can't have two columns that say phone inside of the customers table. And you couldn't have, what's that? Yeah, you could do a 2. So if I did US2, that's different enough that it allows you to create it. You just can't have two tables that are exactly the same name, even if the columns are defined differently. They have to be different names, and inside the table, you can't have two columns that have the same name. So you could do a name. You saw in one table for customer address and address 2. So it'd be like address line 1 and address line 2. Instead of calling them both address. Okay. So let's do a query here. Let's call this ID. It's easiest if we just do it in this order. It can be in a different order. Oops, ID. We want to put those in backtips because name is a keyword in SQL, MySQL. Country code is not. So you can enter it like that. Okay, so now we're going to insert data into that table that we created, but we're going to insert it into US2 in this order: ID, name, and country code. So in your select statement, you're going to want to do ID, name, and country code. From your schema or database in that table you create, no, this is a query, so you want to select from world.city. Went on autopilot there. So we're going to insert into our table these columns that we're selecting from world.city, where country code is equal to, I believe it's USA. And what I do before I insert, I just run this part as a query, make sure it's what I want to insert into my table. It's looking pretty good. Those are like all US cities. Now we can insert all of this query result. We created a query that we could use in the insert into. We'll run that. It says insert into J. Bergman US2. 274 rows affected. So it inserted 274 rows from that query. So you could see how it'd be a lot more efficient than inserting value by value. Okay. So now if we check the results of what we put into that table, we have ID, name, and country code in that jbergman.us2 table. So now we've persistently stored the results of this query into a table that we created in our schema. Now that's what you do. As a data analyst, you do that a lot, is you take whatever part of the data that you want, and then you insert it into your own table for analysis, or maybe you connect to it by Tableau or Power BI. Then you could use the database connector. You go to your own table, and then you're able to do an analysis in it. What's that? Yeah, so in Tableau, it'll have, it won't be in Tableau Public. But I think even I have a super old copy of Tableau installed. Say, don't ask why. And this is part of what we'll do as the final product. but you can connect to MySQL and then connect to that table and just export those results. And that's often what you do to create reports and things like that. Okay. So that is how you do that. Let's go ahead and keep moving through these. We are starting to run short on time. Okay. Just wanted to show you two different ways to insert values, and we'll actually show you one more way before we're done. So updating existing values in a table. Let's bring this back over. Okay. So purposes of updating existing or possibly missing values or known changes based on known changes to the data set and profile. So say you have a record and you know what the update should be to it, like a bunch of null values, you could go in and say update jbergman.customers table. And this is really important. So the set keyword, and you have your field names. These are what values you're going to set it to. And then where the customer number is 103. So this set is really important to get right. And this where condition is even more important to get right. So the set is like what you're going to set it to. And the where, remember the where clause limits the records that you are bringing back in a query or you're evaluating in a query. So making sure you get exactly the right rows that you want to update is really important, and you don't make a mistake and then all of a sudden you update 50,000 rows with these values accidentally. Because imagine 5,000 customers who had different cities and states in Omaha, Nebraska, then all of a sudden you overrode all that data with Omaha, Nebraska. That would be bad, especially if they had no way to recover it. Then you'd have to go in and guess what their city and states were, which you may or may not be able to reproduce that. You could probably do it from address and zip code. That would be one of your less ones, but you could imagine where it'd be really bad. So the result changes the top old record value to the bottom new values specified in the set keyword. So it changes the old one. Remember where we had, this was a city in France and no state. It updated this, updated it where the customer number for that record was 103. And it doesn't have to be on a unique field like that. It could be on something, I don't know, this is a silly, maybe not a silly one, but if the state is NE, where the state is NE, set country to USA, set country equal to USA. Maybe you're going in and they're null for some reason, and then you just set all those values to that. We can go ahead and run that. We'll run it really quick to give these examples. Okay. So we have the update jbergman.customers, like the one that you wrote to your schema. Okay. So it says one row affected. So that's how you know that you got exactly one record that you updated with that. And I always, every time I update, I always check it to make sure it's what you intended. And if you're doing this, at the very least, if you have to do it in production, create a backup of it first. I'll show you how to do one way to do that. Where customer number is equal to 103. Oops. I didn't do that right. Update, select star from, because I didn't do my from today. Like, wait a second, that seems right. Now you see the city and state change to Omaha, Nebraska. So what was it? You're saying, Celeste? Yeah, well, that's what I'm saying. You'll learn that here in a second. I'll show you a good way to do that. Delete records. Okay, so next is delete records in a table. It's exactly the same thing where you set your where clause. Now you aren't updating any values. You're just deleting from the table where customer number is equal to whatever you set it to or whatever your criteria is, your limiting criteria. And then you could select from customers. You delete this record out of here. So we'll go ahead and run it, just prove it. Delete from customers where customer number is equal to 112. It's a success. You deleted one row. And let's just select star and see what's remaining out of this. So it should only really be that one record since there are two records in there before. Of course, I inserted 4 records because I went back and did that other customer number before, those other customer numbers. But you also see when you delete, it leaves null values in that record. Or actually it doesn't. No, it deleted it out of there. Sorry. I don't know why I said that. That's just, it just returns that result set. That last row is null in MySQL. But it did say when I selected it, there are only 3 rows now instead of 4 rows because we deleted 1 row from it. So my mistake on saying it left all the values null because that's not what it did. It was just displaying that. Because we had 4, we deleted 1 record. Now we have 3 records in the table. And imagine in a situation where it's always in the where clause too, making sure that's exactly what you want to do. Imagine if you miss that and you just deleted all the records out of the table or something. You delete 10,000 when you just wanted to delete 5 records out of it. Like you deleted all the customers in the state of Nebraska because you forgot to put the other part of the where clause. That's the thing is like, if you type this in wrong and run it, could do something very, very unintended, what you definitely didn't intend to do. Okay. Okay, so copy table, this is how you can make a copy and like a backup in a way. So you could do this 2 ways. You can oftentimes within these IDEs, if you right-clicked on the table, oftentimes they'll have a table data export wizard, or you'll be able to export it in some way. So in MySQL, you could do this, export it as a CSV file, and then you'll save all that data at that point in time. So one of the things why you can't really trust the database administrators to have it is because they may not have that backup at that point in time. Maybe they have a backup from the night before or the week before. And then potentially you have all these records in here that you wouldn't even know what those records were. So they could be permanently gone if you don't, if they don't have like a recent backup between when they back things up and all of the transactions that happened in the system as of when you deleted things. So it's a whole timeline. But this is what I'd always do. I'd either export this so you know that you have this file and you could always re-import it at that point in time. But really the safer way, even at that, is that you can also copy the table. So you can copy the table by just doing the create table and then selecting star. And you notice when you create the table, you don't even have to list all of the columns in order. They're just inferred, and it infers all of the data types in MySQL. So this is a super way of just backing up a table exactly as like all the columns exist, all the table exists, all the data types, constraints, primary keys, and everything. It will bring everything over that's tied to the table. So we're going to go do all of this. Do I have this in here? View. Looks like maybe I don't. So I'm going to copy this out of PowerPoint slide. Okay. So notice the different parts I have here. Is just kind of partially review. So I'm going to use my schema. So that's going to make my schema the active schema. You'll know that because it'll be in bold. You can start to be a little bit safer about drops too. Instead of just drop table, you can use these keywords if exists. It only drop the table if it already exists. And then you could create this table straight from this query. So let's see how this works. So in 3 parts, use that database. It says that worked great. The second part, drop table if it exists. It only gives you a warning because it didn't exist. It says unknown table. So it wasn't necessarily successful, but it kept running. It was just a warning that just said that table doesn't exist. And then you create the table since it doesn't exist. jbergman.city from world.city. And now let's see what happens. So if we did star from jbergman.city. So it just gave us it gave us 1,000 rows here. And let's select star from world.city. Yep. Select all columns from the table. I should really write these like this since we do these on each line. So you see it gives you the exact same result. So if you select all the columns from Bergman.city, jbergman.city, or your own schema, it gives you 1,000 rows with Afghanistan on top and Netherlands. If you do world.city, it's an exact copy of it. So now we have all the same data in jbergman.city as you do in world.city. And that was because we created this table by selecting star from world.city. And these even have the same data types. So if I were to hit refresh, okay, city, columns. Okay. So you see in my table, big integer for my row ID. It even, it's a primary key because it's underlined. It says PK. ID is an integer, name, country code, district, and that is the same, exactly the same as you have in the world.city table. So it created an exact replica of the world.city table. And why I like to bring this up, because you can do this out of the Sequila database or the world database. You can copy any of one of those tables into your own schema and then work with it, which you'll do for homework number 2. Okay. Okay, one last thing or two last things. Creating a view. Okay. So I have a better description here than I was describing it before, but oops, let's do from current slide. Oops. Okay, it is a virtual table based on the result set of a SQL statement, saved as a database object for future data creation and extraction. So I like that definition better than I was describing it, because think of it this way, is if you create that query, you get a result set, tabular result set. If you create a view, it's like that result set is like a virtual table. So anytime you run this view, you can reproduce that exact result. So like an example here is you create view of world.countries_Asia. So getting all the countries in Asia. And then you select country from world.country, even giving it aliases, where table.continent is Asia. And then if you create that view, you can then use it as like it's a table. So you would say select country, because that's the name of that column that you put in your view. And then from world dot, and then you see instead of using the table name, you use it as a view name. And then where the country is in India, China, and Nepal. So how this query works is that it brings back this result set since it's saved in a view, and it limits the records to just India, China, and Nepal. And you say, why is this important? It's because it's an abstraction of that table. So maybe, like I said, these views are really good for reports. Maybe you have, what's that?
Abstraction or an image?
You can kind of think of it as both, I guess. It's like an abstraction in the sense like it's just a part of the table, and you don't need to know necessarily all the things on the table. You, what you can do is just give it a name and then query it by like your world countries of Asia. It's also kind of like a snapshot of it, but there's also something else called like a materialized view, where it actually in the background recreates part of the table so the view would run faster. Like we don't, that's like database administrator stuff, but in a way it's kind of like that, except
They describe it as abstraction, like the official way to describe it is as abstraction.
a view.
Or, yeah.
Oh, I don't know if that's an official way. Okay, here. Let's ask our expert. We're almost out of time. Here, but we'll go really quick. And abstraction. Database table. That's how I settle all my internal head disputes. It does say a SQL view is an abstraction of a database and not an image of it. There's a materialized views that I had it once in this class, but I just confused people. So I took it out, but it's like a view where you can, it creates part of the table underneath so that you can do this really fast instead of having to rerun it. Think of an abstraction as like, you don't have to know the whole table. You just have to know what's in the view, be able to run it. Okay, so view data is not stored. That's important. It's just like a view into a table, like a partial view into a table. Like cutting out a slice of it.
The table.
What's that?
A slice of like a table, like just like a
Yep. So
department has like country of Asia.
yep. So it's like a view into it or like a window into it.
Right, and how's it different from like query?
Because this is persistent. So once you create a view, you can run it like it's like a virtual table almost, or a view into the table. And we'll see that here in a second. But it's used to call up data without changing its underlying base tables. So it doesn't change anything about a table. You don't create a new table. You're just using a view to do it. Use these all the time for like business logic, like putting a bunch of logic into reports. Did that for a client. Created a view off of the database so that they can just run the view without having to reproduce all that logic. They can just run it and there's your report. Okay, we'll do this really quick. Okay, so view will create, let's see. I must have overlapped part of this. Okay, so create view. So this is under lecture 3, slide 13. So we create view like we're creating a table. Notice that since we aren't creating a table, we don't have to define the data types of all the columns. They just get it from this world.country table. And we run this. Select part, you get all the countries in Asia. We create a view. Creates a new database object. So it's not in tables. Remember, one of the things we had when we created a database is that we could create view objects. And now you see there's an arrow on views with view.country. View, VW, I always put them as VW because it makes it easier to see in the database. It reminds me that it's not a table. And oftentimes with tables, I do TBL underscore. It's just a way I do it to organize things, or stored procedures, SP, and every organization will do it different, but it's a reminder when I run queries that it's not a table and I'm looking around for a table. Once you have this view, let's take the code out of the PowerPoint slide. Say we just want these 3 countries out of it. Now we can run this like a query, except we don't want it in world. We want it in our own schema because that's where we created it. And notice it can be across databases too. So this query comes from the world.country database, but now it's a view in our schema. And now we can run it this way. China, India, and Nepal, because that's what we chose to put in our in. So really simple example, but it illustrates the view being kind of like a view into that table and limiting it to Asia. And then you could use that view to just get whatever you need out of that subset. So really handy. These also persist too. So you can just embed logic into it, or rules, or everything. Really important when you're doing reporting. And so you don't have to reproduce the same report all the time, or like remember all the logic that's stored in a report, or all the exceptions or rules and things like that. You can just add it. You can just keep adding it to it. Okay. All right. So do we have anything else to cover? We do. One other thing is that I wanted to show everyone how to import a data set. So you can add new tables to MySQL in a few ways. You can do it from CSV file. We were talking about that when we is a way to back up the table. You could export all the data out as a CSV and then re-import it. You could also import it as a SQL file, so you could create your own, like by inserting the values like we saw before, or convert a CSV file into a SQL import file. So what I mean by this is if you go to this website and say I have a CSV file, I put one in Slack for us to use. So if you do customers and you download this file, oops, let's actually see this as a text file. You'll see it a little bit better. If I just were to open this in Notepad, comma separated values. So if you aren't familiar with that, it's all the values you have in your top row. You have your columns, or almost always have your columns. And then for each record, they're all separated by a column. So comma separated values. And what you can do here, say you could paste this in. And then it would create a table for you just based on those values. It kind of imply, look at the data and imply. And then you could do these all as insert values. That can be really handy if for some reason you're having problems importing a file. So if I was to paste this in here, it'll create, if we were to use Jay Bergman. Okay. So if we create a table name, we use Jay Bergman first. It'll point to that. If you don't do a table name in schema or a schema.table name, it'll infer whatever the active database is in. So what I mean by that is now if I use Jay Bergman first and create it without saying Jay Bergman.table name, we'll put it in this guy. It put it in table name because I said use Jay Bergman, and that's the active database. And so I created this table to insert all these values into. Then I can insert these values into it that I got out of that website. I mean, it's not perfect because you see there's even one record that for whatever incorrect integer value for postal code. So it inserted most of these, or a few of these, but somewhere in here, there's an invalid value that it didn't like, probably Japan. So it doesn't do it perfectly. You still would have to keep redefining these tables. Maybe you put something in there that allows null values. Or not null or null. That is one point where you'd use null values. Maybe. And this doesn't mean necessarily that all of them are going to be null values. It means if there's no value, it will default to null. Okay. So there are a few ways you can do it. You can also do it through the import wizard. So I'm going to delete this table. And recreate it. Okay, so if I recreate this, you now have table name here. And how you could use the MySQL import wizard is if you right click the table that you create, you'll see data table import wizard. And it says data table wizard allows you to easily import a CSV, JSON data files. We won't worry about JSON. You can also create destination tables. Okay. So we'll navigate to that file, that customers file. Use existing file or existing table. That's the table we created in jbergman.table name. Okay. So you see here, it detected the file format. Encoding can be important because that's how the text inside the file is saved. Sometimes there'll be different formats. But you notice you have a source and destination. So you want to take the columns that are in the CSV file and match them to your table. And all of these have the same name. It's not always the case that they always have the same name. Did you have to match them? And we'll run this and see what happens. Likely we're going to get an error on that same record. Sometimes when you're importing big files in MySQL Workbench, it just takes forever. Yeah, you see it's...
That's why you want to use a different method.
Yeah. Sometimes if you create a table this way, you'll notice you'll either have to clean up the file or you have to do a really good job of defining these columns for a table. And right now it's importing these. Oh wait, this doesn't make sense though. Because I want to import the customers into the customers table, not into the table name. So this customers is actually for the customers table we created earlier in the lecture with the customer ID, customer name, first name, last name, phone number, and so forth. Doesn't make sense to import into the table name. Okay. Okay, customers, wherever that file is located. Let's import that into the customers table and see if that goes a lot better, huh? Customer number, name, last name, first name. That was looking pretty good. And the credit limits. Because I generated this example before class and still didn't work. Yeah, so oftentimes there's a bunch of work that needs to happen to the files and the tables to import it. That's probably one of the more painful things. And data engineers often do that work too. Whatever gets it working for you, part of homework number 2 will be to import the data that's given for the homework into a table. So if you have a lot of problems with that, please let me know. Okay. So for class tonight, we are going to only have a few minutes for review. Okay, we learned data definition language, how to create tables and databases and views and all sorts of good stuff, and tables with constraints. We learned how to insert data, update it, and delete it once it's in the table, and importing data from SQL and CSV files. So SQL by inserting it, the values, and by the value statement, and using import utility, which I struggle with it in Workbench. Oftentimes I'll use Python instead. I'll import it into Python, and then you can connect it to the database and then just write all of that. Won't do that in this class. I do have an example if anyone's interested, but won't require that in this class. Okay. Lots of additional resources for data. They're all out there. I like sports data, and Kaggle has a ton of good data science competitions and challenges and data sets that people have created. If you want to just load something up, or census data from data.gov, if you want to play around and load some data and do different things with it. And that is it for this lecture. So the exercises, to cover this real quick, it's like the things we talked about is creating schemas. And since you don't have permission in the database, you just write an example code for it. And then creating a table, missing persons with the following qualities. So you could do fields, IDs, and field constraints. You can add it. You would add a field. We learned how to do that today. You can add column, and you could add a gender to last name, first name, age. So this is like a missing persons table. Insert those values by value. Delete a record by last name. So there's one with Elvis Presley in it. You update a record with ID is equal to 4. So instead of having Tupac's name there, you'd have Tupac Crooks. Drop column, first name. So just drop that column, and then drop the whole table from your personal schema. From, as it said, say personal schema. So everything that we covered in the lecture today, a pretty simple example, but I'll drop that code here. And I feel as though I owe everybody a couple of guided examples. So just for a show of hands, how was the examples from, how did you do with the examples from lecture 2, the writing queries? Was everybody good? Be able to reproduce these? Or could they use a walkthrough or anything? Didn't do it. If you're the adventurous type, you could just jump into the homework instead of doing the practice exercises. You don't have to do the practice exercises. I intend to get to these before like the last 5 minutes in class, so that I could give guided exercises. But if anybody would like me to do guided exercise of this or this, I could record both. Won't be tonight though. Yeah, I'll go back and record both of these. Sorry for not getting the other one over the last couple of days. So I'll record both of these as guided walkthroughs, put them as videos. Okay. Did anybody else stay as long as needed? Did anybody have, well, actually, I should introduce the other homework too. I'll do this really fast. Yep. So inside of Slack, I believe I put the homework in here. Homework 1 today. Okay, I put the quizzes. Homework 2 plus CSV file. So it looks like I just put the CSV file in here. So you'll use this. You'll load this game rental history into a table in homework 2, and I'll give you an overview of what we're trying to accomplish here. So it builds on homework 1 as far as doing that exploratory analysis and discovering different opportunities in the data and just understanding more about the video store and its inventory challenges and sales challenges and customers. So the second homework, I'll put it in here. Let's see. Let's see. 1 second. Nope, that's not it. Go ahead and put this in. We'll put this in. Slack for you. And this won't be due until Monday of next week. So if you haven't completed the other homework, please complete that other one. I'll give you time to do this one. And we'll make it gradable by Wednesday because of the short turnaround, but I will give you next 7 days to do it. So class 2 homework, give you an overview of this. Okay, so homework 2 is data storage and manipulation. We're using the concepts that we learned tonight. So following that initial analysis you did in homework 1, so setting up the database and connecting to it and running queries on it, of the classic DVD rentals. The CEO was obviously impressed by your insights. Now she wants to implement some changes to the database structure and operations. So what they want to do is expand their business to include video game rentals and need your help setting up the necessary database infrastructure and importing historical game rental data into their pilot store. So very common. Oftentimes I work with clients. They come across a challenge, but they aren't capturing the data yet. And you have to help them with a way to start capturing that data so that they can analyze it. Creating a database and database table can be a good way of doing that. So part 1, you're designing a table and loading it with that initial data. So create a new database. You won't be able to create that database, just write the code for it, just like we saw in class. But inside of your own schema, you can design and create tables. I give you 3 tables here to create. So it's video games. So you have a game table, platform table. So platform would be like Nintendo Switch or other PlayStation 5 or other things like that. And then a publisher table. So the publisher of the game. And I give you the information for this in the CSV file. So include the appropriate what you believe to be appropriate constraints. Then SQL, then write, then give me a screenshot in your SQL code that you do. Then insert the data, create a view, then modify the table. You can add new fields and update, delete table that's inside, or update those tables that you create. And I'll have to go look. There's a game rental CSV file. And I will make sure that, oh no, that's the only CSV file you need because we insert some of this initial data using insert statements. So pretty much everything we covered, pretty comprehensive of what we covered today. Always, if you get stuck importing data or the assignment's just too long, please let me know. These can be challenging, defining these tables in the way that you need to. What's that?
I just didn't have a chance to do it last time. Like, I didn't even have time to.
Yeah, that's what a couple people said that.
You know, like,
It's okay. I'm
playing, you know,
flexible on all of it, and
I could
please.
do it, I just left like 3 hours. And I was like, this is not enough time to do these.
Yeah, please let me know through Slack if you have questions, and I'll do my best to answer it in a timely manner. that's the homework. It's out there. Make sure you download that CSV file that goes with it, game rental history, and then trying all these different things. So yeah, you'll definitely get a workout by the time all of this is done. Yep, you're welcome. Anybody have any questions about the homework or anything about the class so far? I'm happy to answer them. Anybody stuck on any part of the homework?
So this assignment's due Monday. Will there be another assignment that is assigned Wednesday due Monday as well?
Yes.
Okay.
Yep, so you don't have to
2
start
total
it
due
all.
Monday.
Yeah.
Okay,
Sure.
cool.
And then I'll, like the homework that everybody just handed in, I'll review that on the Tuesday afterwards. And we also didn't cover the quiz, did we? I have some work to do on that, so I owe the class a lot of feedback. I have my work cut out for me too, so you guys aren't the only one. Part of teaching, the joy of teaching. It's a lot of work that goes on behind the scenes. Be a good teacher, instructor. Happy to help anybody who needs any here after 9 o'clock. I'm here for a little while longer anyway. We do pack a lot into this class. I look at the lectures before and I'm like, oh, it's only 15 slides. We get through that really fast and have plenty of time. We do pack a lot into these. But I said you pretty much know everything, at least from a data analyst perspective and working with data. And you know quite a bit about relational databases by the end of the 4 weeks. Well, yeah, intensive course. Happy to answer anything, or if you later have any questions, either drop them in the SQL101 channel or you can directly send me a message. Either way. And I'll also look over quizzes tomorrow and see what's going on with those. But you know, provide feedback and start grading homework 1. Record some videos. Oh. Well, seems like it's nice outside, 65 degrees. I didn't miss it. It was warm before I got in here too. Still warm tomorrow. Enjoying the weather. Yeah, I don't want to keep everyone cooped up when the weather's so nice doing SQL homework, but best way to do these things eventually after all the learning is just going hands-on, I think. And trying to provide examples, concrete examples while we go through lectures and see how things actually work. Oop. Yeah, any questions? You're the last man standing.
No.
It's just a lot. Yeah. Get it.
Moved on to checking on something and a space out. But hey, enjoy St. Patty's.
I will. I could still get a beer pretty easily. It's only 9 o'clock.
Nice. I have a medical tomorrow morning early, so unfortunately I'm gonna have to.
I know. I have like responsibilities and everything, so I can't. I really can't either. I'll just go home and have a beer.
Yeah, I'll talk to Big Talk, but I probably won't even have one. but I'll live through you if you do. So.
Yeah,
Enjoy
it's
your
tempting. Downtown has some good. They have good Irish pubs down here.
Oh yeah.
Even just up here on Leavenworth, there's
Barrett's.
I can't think of the name. What's that?
There's Barrett's. There's
Barrett's.
Mary something. Oh,
Barrett's
Barrett's is probably crazy right now. Hopping, I can only imagine.
I know they have good hash on. They have good hash on. Like was I thinking? It's like corned beef and hash with like hash browns. Like theirs is like the best. If you go in the morning, if you start in the morning.
Oh yeah.
I've done that. I've done that one before. Start at like 8 in the morning. Makes for a long day. But it's actually
Have Tiger pour you a tall one. I used to live there, so I even know the bartenders by name there. A good Reuben.
Yeah, the Reubens are good too. The food's excellent. Must have been like 2018. It's been a few years. Went out with some friends. That's probably the last time I did. Before my third daughter was born. Before my third daughter was born. It's probably the last time I went out for St. Patrick's Day. Otherwise, I just take the beer home and have a green beer and fall asleep. That sounds pretty good too, though.
Our daughter will be 5 next year, so I'm very tempted next year to recuperate for all the 4 years, and then my wife and I to get out and enjoy it a little bit.
Yeah. No, that's about right. About 4 years old is when you start. It's hard to travel before then too, or leave them alone for that long. That's when it starts to get a little bit better. Grandpa and grandma can handle them a little bit better.
Yeah.
At age 2. Otherwise, you're changing diapers, maybe through 2 and maybe even 3. And just hard to travel in general.
We could probably get away with it now, but we're a little bit overprotective still, But I think by 5, we should easily be able to.
The first is always like that. Then
Mm-hmm.
Then you've been through it, and you're like, oh yeah, not as much to worry about. It's always the first one though, because I don't know. It's just your instinct, I guess, to go the opposite direction and protect them.
Yep, it's
But then
everybody says after the first one, then
it's going to be easier. Yeah, it's you don't exactly know what you're doing. That's like the first thing I thought when I brought my first daughter home years ago. She's 16 now, but I'm like, man, what did I get myself into? What do I even do? So you figure it out. You have like the instincts for it and everything.
Definitely a different ballgame being a girl dad. Like, if I watch a movie and all my instincts kick in, protective and watching and making sure she's okay. Different. I'm not. I know you have to get ready, so I'm not going to keep you. But hey, thanks for everything. It's good class. I'm learning a lot. I appreciate everything.
Yeah, a lot more to come here. Coming up in class, it goes by fast. So almost halfway done, but it's a lot.
We're
actually probably.
Mm-hmm.
Probably consider it more like halfway done, because now I don't have a final lecture either. I took one out so that I can do final one, work on the final project. and then give everybody time to finish homeworks. But if you do all the homeworks, then that's like your final project. You're done with the final project. So that's
Sounds
something.
good. I started very late on mine. I need to finish and I need to hit the bed, but tomorrow I'll be. I apologize. I know you're checking them tomorrow, but sometime
Oh, no
tomorrow.
big deal. It's a mad rush for me too, so no worries. That's why I let people just spread it out over time too. It takes a lot to grade. I saw on your LinkedIn profile, Matt, that you taught also.
Yeah, I taught quite a bit. I was one of the folks that started teaching online before COVID. So weirdly for me, it was a smooth transition. It was actually we had began in a small community of us trainers. I lucked out for a little while. The agile community was at the forefront of training and experimenting with cool stuff. Not so much anymore, but I was in a small community that people were wondering, could that online, could it work? What can we do better? People were starting to do 3D stuff and crazy stuff. I was connected to a group in California, in San Francisco, and before we knew it, it was real for everybody. It just happened for us, but for me, it was easy in. Yeah. It's I don't think people can appreciate how much prep and how much energy goes into training. Even stuff that I know like the back of my hand, and still I have to kind of think through it. And you also have to entertain your own brain, because my brain starts dying after a while, repeating the same stuff and kind of going through the same materials. So I was smiling when you switched homework, because sometimes that switch to exercises as much for me as for people, just so I'm not getting that tunnel vision, if you will.
Yeah.
But it's hard. Mm-hmm.
Every class, though, I find something to improve in this, so I do like incremental improvements. So it's always a little something for me. Or like I find out that the quizzes don't work like I thought they did, or something like that. So it's still keeping me pretty lively, I guess, after like 7 times of teaching it.
Oh, it's
I guess maybe it's like I only teach it once or twice a year. Maybe that's part of it too.
Oh, it's definitely is a rush, but at night, it's I know what it's like. When you have the energy, you get the rush at the beginning, and then after a while, it's like mentally, and even if you doesn't matter, you could teach 1,000 times. After a while, it's just draining, to train. Sometimes, even on a good class where people have epiphanies and like we're rocking and rolling, I'm all jazzed up, and then I hit, or the class ends, and 5 minutes later I'm like, wow, I'm dead tired. It's like I've been running all day.
I'll probably I'll get something to eat and be out maybe just a little bit after 10 here. I go up pretty fast too. And
hey,
then
I better let you go so you can wrap up. But hey, thanks. It's a great class. You're doing great. You're doing great. One unsolicited tip.
Yeah.
I never know. It's kind of a black box when people turn off their cameras. I randomly, not to like prod on them, but I'll be like, does it make sense? I forget the guy's name, like Lazarus, Matt, like Natalie. Natalie, were you good? Right? Like not necessarily prod to put her on the spot, but just saying like, hey, Natalie, you good? You good? Like just get some kind of reaction, be like, but it kind of gets them going, and that they're with you. That's what I do.
I've done online training where they call people out for.
That's different. Like, what did you get for that exercise? And they're like 2 steps back. That might be a lot of. I sense that some of these folks, even the concepts are new to them. So I can imagine, like I did a ton.
I just try to be as available as possible, and then it kind of shows at the end, I guess, like the work that they put into it. So as easy as I am on or as easygoing as I am with grading and homework and everything, I still sometimes don't pass people, and I could tell mostly who those are going to be. But trying to get them engagement. It's easier. I feel it's really easy when people are here in class, but no, engaging people online is something different. I'm still working on it.
Yeah, I'm surprised.
But yeah, that's a good idea to just
Yeah.
ask somebody, or that's moving pretty fast there. But you guys are a good group. This one's a good group. So you guys ask questions.
These are really good guys. I'm so glad that we're moving together. It's just a good chemistry. You know, we haven't done a project together, but it seems like, you know, just by talking back and forth. But I'm surprised that they're doing hybrid live and online. It just takes so much more things to pay attention to as a trainer.
Yeah.
I could never figure out what works. You guys have got it down pretty much, but I could never figure out if I'm having people present and repeat and do kind of teach backs where people are, a lot of times we'll do a dog and pony show and like, hey, what was your experience at work? How does that relate to you? You know, kind of a lot of that feedback. And when you do it hybrid, it's different energy on one end, different energy on the other. And it's so hard to sync it and kind of have it flow, you know? So,
Yeah.
but for you guys, I feel like you're moving fast, so it works. You kind of, people have to really pay attention to stay and be focused for this. So I think it works.
Yeah.
Cool.
No, it helps having Celeste here. Is like I can there's somebody to gauge in person too.
Sorry, I was planning on coming, but I get to drive and I barely made it home. You know, downtown, I would have been easily missed the quiz and everything. So I'll try to come on Wednesday, I promise.
Yeah, no, it's no problem. I had one person to gauge, and I know if she's getting it, then probably most of the people in the class are getting it. She's getting engaged. She's doing a nice job tonight too.
Yeah, she's asking good questions. Like, you know, the people that are farthest from it, they're getting a lot. You know, her world is blown up right now. She's just thinking through what database means and all that stuff. So good stuff.
Yeah. Connecting it to what you might see in real life here too, in the work environment. I've been through a lot. I feel like a veteran of data or something.
Yeah, this is cool. I mean, I've queried stuff, but I've never manipulated, so I can't wait to start seeing it. You know, like all that stuff. My only thing is, am I gonna use it as much? Is it gonna be like a bike? I think it will still come back easier once I've done it before, you know, and hopefully it's sooner for me, you know, that you know, I either get a gig that I'm doing a lot of querying or, you know, manipulation, just so that the skill stays sharp. Because, you know, but once you've done it, if you've done it once, even if you have to go back and look it up, you're making the connections much faster. You know, it's just a matter of refreshing versus learning it again. So. Yes, sir. Hey, I know I'm keeping you at St. Patty's.
No
You're
problem.
still downtown. I will see you Wednesday. Thanks again. Good class.
No problem. Appreciate it. Talk to you later, Matt.
Talk to you.
Bye. All right. Let's go ahead and end this lecture. All right. So the next lecture in the data management and manipulation SQL 101 class will be class 4. This will be joining and merging data. But when we talk about relational database, this is relating data together. So data that are in 2 separate tables, joining them by a primary key and combining data sets. There are a number of ways that you can do that. And merging and appending data. So doing a union or union all to make one long data set. So putting one data set table on top of another to create a unique data set. Really, what data analyst is all about is generating novel data sets and insight into the data. So getting the tools to do that through joining Emerging Data will be the next lecture on Wednesday. So this is Jeremy Bergman, the professor instructor for the Omaha Data Science class. I'll see you then.